All right, this is Ms. Triangle. This is the 5-5 side, or SSS theorem. So start by putting the date and the topic, 5-5 side. I abbreviate that as SSS theorem. It is another shortcut for proving two triangles are congruent. So our essential question, our EQ, what is the side, and the hypotenuse leg theorem? Our learning target, 5E, I can use the side, the SSS, and the hypotenuse leg theorems to prove two triangles are congruent. So these are other shortcuts besides side angle side that you can use to prove two triangles are congruent. Okay, so again, you can summarize. We have a question, what is the side theorem? Okay, so basically I would draw the picture. It's basically if you know that all three sets of sides in two triangles are congruent, if all three sets of corresponding parts are congruent, then you can say the triangles are congruent. Okay. Then there's a special case called the hypotenuse leg theorem. This only works for right triangles, okay? It only works for right triangles. And it's if you know that it's a right triangle and you know the hypotenuse. Remember, the hypotenuse is the diagonal or the side across from the right angle. So AB is a hypotenuse, DE is a hypotenuse, and then one of the legs. You don't need both. So pause the video, write down what you need for this. You don't need to write down everything, but there should be something. Here's the diagram that reminds you of what the hypotenuse and what the legs are in a right triangle. All right, so example 1. Write a proof. You need all of this. So pause the video if you need to. Write a proof. Given that KL is congruent to NL and KM is congruent to NM, prove that triangle KLM is congruent to triangle NLM. So I have two sides right now. I have two sides, but I can add this third side right here because they both share that side. If I were to break it apart, they share that side using the reflexive property. So I'm going to go ahead and make my statements and my reasons. So my first line, I always start with what's given. So I'm going to say KL is congruent to NL. That was given. KM is congruent to NM. That was also given. And the third line is going to be that third side, which is the blue line, LM. So LM is congruent to LM, and that is the reflexive property. And then now that I've said all three sides, side, I can say that triangle KLM, I can end with the question, KLM is congruent to triangle NLM, and my reason is the side theorem. So pause the video if you need more time. I'm going to go on to number 2. All right, so make sure you get the diagram, make sure you get the problem copied down. So pause the video, write a proof. Given that WY is congruent to XZ and WZ is perpendicular to ZY. So it may be helpful if we draw these triangles kind of split apart. So WZ Y and Z X Y. Okay, W Y Z. All right, so then I'm going to go ahead and mark up my drawing. So it says WY is congruent to XZ. So I'm going to mark that on my picture. WZ is perpendicular to XY, so this is a right angle. And XY is perpendicular, so this is also a right angle. So I know that I have two right triangles. Okay, so I know I have a right triangle. I know the hypotenuses in red there, the hypotenuses. I need to also say that a leg, though, is congruent to use the hypotenuse leg theorem. So do they share anything? Yes, they do. They both share ZY. This side at the bottom here, ZY. So then I can go ahead and use the hypotenuse leg theorem. Okay, so let's go ahead and set up our two-column proof. So I'm going to start with what was given. So I'm going to start with this. WY is congruent to XZ, and that was given. I'm also going to say that these perpendiculars, I'm going to make this all one line. WZ is perpendicular to ZY. XY is perpendicular to ZY. And that is also given. All right, so next, now that I've done what's given, because I know that these are perpendicular, I know that they form these right angles. So I'm going to go ahead and say that angle WZY and angle, so that's this angle WZY, and angle XYZ are right. Okay, that's kind of the definition of perpendicular lines. All right, so then I can go ahead and say, I'm going to have to zoom a little bit. So I'm running out of room. Then I can go ahead and say that I have right triangles. So triangle WYZ and triangle, so WXZY are right. And my reason is just the definition of a right triangle. A right triangle has one right angle. So now I know that I have right triangles and I have one pair of congruent sides. Then I need to say this green side, ZY, right here, ZY and ZY. So I'm going to say that ZY is congruent to ZY. And the reason is the reflexive property, they share that side. And so lastly, I can end with what's given, that triangle WYZ is congruent to triangle XZY because of the hypotenuse leg theorem. So I can use that for a right triangle, and then I only have to have two sides, and I have to know that it's a right triangle. All right, so pause the video if you need more time. I'm going to move on to our last example. All right, the television antenna is perpendicular to the plane containing points B, C, and D. So those are all right angles. Each of the cables running from the top of the antenna to B, C, and D has the same length. So those are all congruent, and that's marked on your picture, right here. Prove that all three triangles are congruent. Okay. All right, so let me set up my statements and reasons. So I'm going to start with all this stuff that was given. AE is perpendicular to EB. Okay. AE is perpendicular to EC. And AE is perpendicular to ED. So I'm just doing all these right here, and that was given. I'm also going to do the next line right here. AB is congruent to AC, and I'm going to have 3 because I'm proving 3 triangles are congruent, and that was also given. All right, then I'm going to talk about all 3 triangles share AE. They all share that middle line. So I'm going to say AE is congruent to AE is congruent to AE. And what properties? You should kind of be recognizing this. That's the reflexive property. Okay. And then I just need to say that I have those perpendicular angles. So angle AED, angle AEC, and angle AEB are right angles. And just like our last problem, that's the definition of perpendicular lines. Then I need to say that I have right triangles. So next I'm going to say that all three triangles are right. So triangle AED, and the order doesn't matter, AEC, AEB are right. And just like the last problem, I'm going to say the definition of right triangles. And then lastly, I can say all three triangles, I can end with what they're asking me to prove. So triangle AEB is congruent to triangle AEC is congruent to triangle AED. And again, it's a right triangle with the hypotenuses and a leg congruent. So this is the hypotenuse leg theorem. So pause the video if you need more time. I'm going to go to the summary. So what is the side-side theorem? What is its purpose, right? It's a shortcut. Instead of having to say all three sides and all three angles, you only need three sides. What is the hypotenuse leg theorem? And how is it related? Thanks for watching. Have a great day.